Hello, welcome to the video. In this lesson, we're going to be looking at section 11.4, where we are going to look at two-way tables. So, the question they ask us is, how can you read and make a two-way table? So, first off, let's take a look at a two-way table. So here is an example of a two-way table. The question that was posed was as a freshman or a sophomore, do you use some type of, or do you have access to a mobile device? All right, so you had freshmen answer yes or no, you had sophomores answering yes or no. So what they're asking us here is they want you to find and interpret what is called marginal frequency for the two tables. All right, so marginal frequency is the sum of the two rows and columns in a two-way table. So what we can say is this: our marginal frequency is, we can kind of extend our tables here, and these are kind of totals. So so what we can now say is there were 55 plus 22, which is 77 freshmen took the survey, and 63 plus 12 gives us 75 sophomores who took the survey. Between freshmen and sophomores, we can say that 118 said yes, they had mobile access, and we could say between freshmen and sophomores, you had 34 that said no. So hopefully, if I took 18 plus 34, and I also took 77 plus 75, we should get the same value of 152 freshmen and sophomores took the survey. So that's how we can kind of interpret these two-way tables. All right, so we can figure out how many total freshmen took it. We know how many total sophomores we took it in this particular instance. We know the number of yeses, and we knew the number of nos, plus we knew uh, the total population of this survey. Okay. Here it says you conduct a survey that asks 286 students in your freshman class whether they play a sport or a musical instrument. 118 students play a sport. 64 of those students play an instrument, and it says 93 of the students do not play a sport or an instrument. They want you to organize the results in a two-way table and also include marginal frequency. So if I make my table here, so like this is talking about like the instruments, and then this is yes, this is no, this is talking about sports, this is yes, this is no, and then talking about the marginal frequency. So we're going to talk about the totals. So we have totals here. All right. So let's look at, so we had 286 students in the survey. So we know that 286 is going to be located right there. Next, it says 118 students play a sport. So 118 students, yeah, 118 students play sport. So that's not, so 118 students play sport total. Um, so that will go here under yes. Uh, let's see. And 64 of those students play an instrument. So this would go under 64. So this would go under yes under instrument. Okay. And let's see if there's anything else we have here. 93 of the students do not play a sport or an instrument. 93. So no and no. So 93 would be both no and no here. They want us to organize the results in a two-way table and include marginal frequency. So basically we have to fill in with the rest of the boxes. So using a different color, I can figure out if you how many individuals do not play a sport be by taking 286 and minus 118, and that is 168. All right. I can, now that I have this 168 total, I can now determine if yes, you play an instrument, no, you play a sport by taking 168, subtracting it by 93, and you'd get 75. Okay. Now that I got the 75, I can now find the total people that uh, play instruments. So 64 plus 75 is 139. All right. Now I can determine the total that that surveyed on instruments, either yes or no, by taking 286 minus 139, and I can say that this is 147. Now that I know the 147, I can now determine that yes, you play a sport, but no, you don't play an instrument by taking 147 subtracted by 93, and that gives you 54. So this is a two-way table that included the marginal frequency. So you had your yeses and nos, whether you played an instrument or a sport, and you had the totals um, with that. So this is the total number of people in the survey. Basically, what it's telling us is 118 students play a sport, 168 do not. 139 students play an instrument, 147 do not. So if you're asking, um, do they play a sport but no instrument? That'd be 54. Do they not play an instrument? Do they not play an instrument and not a sport? That's 93. So that's how you can kind of determine it from there. All right. Some other concepts that we're going to look at. One of them is joint relative frequency. Joint relative frequency is the ratio of frequency that is not in the total row or not in the total column to the number of values or observations. And then marginal relative frequency is the sum of the joint relative frequency in a row or a column. When you are trying to find relative frequency in two tables, you can use corresponding decimals or percent. So either one um, is fine. So with that, what we have here is we have a two-way table that shows the results of a survey that asked college-bound high school students whether they are planning to major in a medical field. Make a two-way table that shows the joint and marginal relative frequency. Okay, so what we can say here is, all right, so if you're a junior, looks like 124 students said yes, 219 said no. As you're a senior, 101 said yes, 219 said no. So actually, I'm gonna kind of extend this and look at the marginal frequency, so I can kind of get some totals here. So if I added 124 plus 101, I get 225. Uh, 219 plus 236, I would get 455. When I added those together, I would get 680. Let's see here. So 101 plus 236 is 337. And then 124 plus 219 is what, 343. All right. So basically what this is going to tell us is that 680 students took the survey amongst college-bound juniors and seniors. And we have the number of juniors in the survey, we have the number of seniors in the survey, we have the number of yeses, we have the number of nos. So, in order to make this marginal relative frequency, we're going to look at the percentages. So, if I were to kind of make this into a table as well, so I have juniors, I have seniors, I have my yeses, I have my nos. So what it's going to look like is what you are going to do is you are going to take the total 680 and you're going to find the decimal or the percentage of each yes and no in this particular table. So the first one, juniors, yes, was 124. So it's 124 divided by 680. So I get something about 0.18 as my, or if you write it as 18%. Okay, either one. Look at the senior one. We have 101 divided by 680. That gets us to something like about 0.15. Okay, so if I added those together, I would get 0.33. So it's about 33% of juniors and seniors say yes. If I looked at the no's, 219 divided by 680, I would get about 0.32. And I would get 236 divided by 680, I would get about 0.35. When I added those together, I'd get 0.67. So now what I'm going to check on is just to make sure that these totals will add up to 1. So 0.33 plus 0.67 adds up to 1. That's good. 0.18 plus 0.32 is 0.5, and 0.15 plus 0.35 is equal to 0.5 as well, and 0.5 plus 0.5 is 1. So you got to make sure the sum of the marginal relative frequencies in these totals for the rows and columns add up to 1, in which they do. So what does this mean with respect to the original piece of data? Well, you can say, like, let's just look at this one. Let's say like this one right here. All right, so 0.18 juniors say yes. So if you could say about 18% of the students that are juniors are planning to major in the medical field. All right. So if I looked at this one here, you could say that about 35% of the students that are seniors are not planning on majoring in a medical field. You know, this stat here says that about 50% of the students in the survey were juniors and about 50% of the students in the survey were senior, you know. So that is how you can kind of interpret this with respect to the original two-way table. Another concept that we're going to take a look at is conditional relative frequency, which again, this is a ratio of a joint relative frequency to the marginal relative frequency, you can find a conditional relative frequency using a row total or a column total of the two-way table. All right, sounds like a lot, but here is kind of breaking it down on what they're looking for. So what we're going to do is they want us to use that example that we just did using so 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 this one right here. So what I'm going to do is I'm just going to copy all of this over. Okay. Whoops, went too far. So if I So I copied all this over, okay? So this is just what we just created. So they want you to use this example here, making a two-way table that shows conditional relative frequency based on the column totals, okay? So what we're gonna do is we're gonna look at this table here, and we got our juniors, we got our seniors, we got our yeses, and we got our no's. So what we're going to do is you were going to take that decimal. So like for the first one, which was 0.18, it's going to be divided. It says it's going to be a ratio of the total percentage that said yes between juniors and seniors. In this case, it was 0.33. From here, we're going to get another decimal or another percentage. When you divide these two, it's going to be about 0.55. Over on the bottom, we have 0.15. That's going to be divided by 0.33. And then we divide those together and we get something about 0.45. Looking at the nose for juniors, it was 0.32. That is going to be divided by the total, which was 0.67. And you get a value of 0.48. And then finally, we had what, 0.35, divide that by 0.67, and that's going to be equal to 0.52, okay? So again, then you ask yourself, what is the relevance of those percentages? So let's just say if we looked at this percentage here, where it's under juniors and it's under no. So what we can say is, given that a student is not planning to major in the medical field, we can then say the conditional relative frequency that this student is a junior is about 48%. Okay. Or we could say something. So if we look at this one here, is given that a student is planning on majoring in the medical field, the conditional relative frequency that this student is a senior is about 45%. Okay, so that is where um, the relevance and where the data is coming from, or what they're trying to interpret from the data. Okay, so here it says you survey students and find that 40% exercise regularly, 35% eat fruits and vegetables each day, and 52% do not exercise and do not eat fruits and vegetables each day. Is there an association between exercising regularly and eating fruits and vegetables each day? So we can make a table here. So like on the top, I'll use exercise. So this is under yes, this is no. We have fruits and veggies, this is yes, and this is no. Okay. So here it says you survey and you find that 40% exercise regularly. Okay, so whether they eat fruits and vegetables, we don't know. We just know that we can say that 40% of the people in the survey exercise regularly. So it's going to be a yes for exercise. 35% say they eat fruits and vegetables each day. So 35% will go right here under the total. 52% do not exercise and do not eat fruits and vegetables. So it would be under no, it would be under both. And let's see here. It says they're asking if there's an association. So what we're gonna do is we're just gonna fill in the two-way table with the with these frequencies as well. So what conclusions can we make of this? Well, I know that this has to be 100%. So if this is 100%, that means that this is 60. And if that is 100%, that means that this has to be 65. All right, so now that'll help us. So if that's 65, 65 minus 52 is going to be what, 13% right there. 60 and 52, if I subtract that, I get 8%. And that's enough. So 35 minus 8 will give us, what, 27%. Okay, so we have this. So now, in order for us to make an association between exercising regularly and eating fruits and vegetables regularly, what we're going to do is we are going to make the conditional relative uh, frequency table. All right, using the columns and stuff like that, like we did with the original example. So just I'll put exercise here. I got my yeses. I got my no's. I got my fruits and veggies. I got my yeses and I have my no's. Okay, so what goes in yes and yes is going to be, I'm just going to write them as decimals. This is going to be 0.27 divided by 0.4. So 0.27 divided by 0.4, I'll just write it in. 0.27 divided by 0.4 is about 0.68. Over here, it's going to be 0.13 divided by 0.4, which is going to be equal to 0.33. For the yes and no's, it's going to be what, 0.08 divided by 0.6, which is about 0.13. And so this is 0.52 divided by 0.6, which is equal to 0.87. So here, they're asking, is there association eating, exercising regularly, eating fruits and vegetables? That would be this number here. And so what we can say is, because of the conditional relative frequency, that about 68% of people who took the survey um, do both exercise and eat fruits and vegetables regularly. I would say that yes, there is an association that if you exercise regularly, you probably eat fruits and vegetables. All right. And that is being able to be able to interpret two-way tables. Hope this helps. Until next time.